Often in the lab, scientists need to calculate how much a sample's temperature will change if the sample is heated or cooled. The formula on the right can be used to calculate how heat energy will affect temperature. Delta H means change in enthalpy. Q stands for heat energy. M is mass. Cp is specific heat capacity. And delta T is change in temperature. That's temperature final minus temperature initial. Let's solve a specific heat problem. Here we're asked to calculate how much heat energy is needed to heat a 125 gram sample of water from 10 degrees C to 40 degrees C. Remember that the specific heat is dependent on the element or compound. Here we have water. It's dependent on mass. And we have our temperature change to help us calculate how much heat energy was needed. So 10 degrees Celsius is the initial temperature, and 40 degrees Celsius is the final temperature. That will be important. The first thing we have to do is look up the specific heat capacity for the substance in the problem. So water's heat capacity is 4.184 joules per gram degree Celsius. The next thing we're going to do is rewrite the formula. The change in enthalpy is equal to heat energy Q, which we're interested in, mass times your heat capacity times change in temperature. So Q is equal to 125 grams multiplied by the heat capacity of water, 4.184 joules per gram degree C, multiplied by the temperature final minus temperature initial. Now you can use your calculator. Q, heat, will be in units of joules. And there you have it, 15,690 joules. In this example, the change in enthalpy is a positive number. That's because the temperature change is a positive number. We've increased the temperature from 10 degrees to 40 degrees. When the change in enthalpy is a positive number, heat energy is being absorbed. If in this question the water was being cooled from 40 degrees to 10 degrees, the temperature change would have been a negative number, and the enthalpy change would have also been a negative number. The heat energy would be removed from the water in this instance. Solving for initial temperature using the specific heat equation can be a bit tricky. So let's solve this problem. What was the initial temperature if 250 joules of energy were applied to 100 grams of iron and the final temperature of the iron was 175 degrees Celsius? The first place to start would be looking at the specific heat capacity table and looking for iron's specific heat. We also know the mass. Mass of iron is 100 grams. We know how much heat energy was applied. And we know the final temperature. We start with the same place. Q is equal to M Cp delta T. Q in this case, 250 joules, is going to be equal to 100 grams of iron multiplied by the specific heat. And what I'm going to do right here is I'm going to leave delta T. I'm going to be solving for delta T. I'm not going to put TF minus TI and try and solve for TI. This is going to save me some headaches. What I'm going to do is 250 joules is going to be equal to 44.4 joules per degree C, just simplifying this right here, multiplied by our change in temperature. So if I'm looking to solve for the change in temperature, I have to divide both sides by 44. For delta T, we have to divide both sides by 44.4. And that is the change in temperature that we just solved for. So the temperature has changed 5.63 degrees. Delta T is equal to the temperature final minus temperature initial. Now we're looking to get Ti by itself. You could subtract 175 to each side. You have a negative sign in both the left and the right, so what you could do is multiply each side by -1. So that's it. That's our initial temperature, Ti, 169.37 degrees Celsius. So we had to put in 250 joules to raise the temperature from about 170 to 175 for this 100-gram sample of iron.